In today's lesson, we will look at sets, that how are sets actually used in Python language, and how is their efficiency better than lists. Basically, the concept of sets is exactly like the concept of maths, like how we have studied sets in maths. Sets in Python work on the same idea. In it, no entry is duplicate. They are mutable and also immutable too. Mutable sets are those whose values we can change with the passage of time according to the needs of the program. Immutable, which we cannot change during the execution of the program. Its main advantage is that it is very optimized as compared to list. In it, if you have to check if an element is duplicate, how that duplicate can be removed, and it can be searched very easily. Lists can include duplicate values, but sets cannot include duplicate value. Aside from that, we align or index our values in it using the hash value. In these sets, against hash table, there will be a key or there will be an index, and against that index, more than one value will be placed. You can say it in this way, that against one index a whole list will be placed, which you can call linked list in programming language. Linearly iterable linked list, which can be iterated in a linear way. I have attached a small diagram in which it will be easier for us to understand sets. Actually, in sets we index value pair in hash table. Now how does the hash table actually work? What happens in the array or list against that index is that only one value is placed against that index. But the biggest benefit of sets is that on one index more than one value may be placed. Like how in our index 5 there is 20 and 30 also. 40 is on index 6. 50 is on index 8. So actually a whole linked list can be built up against every index. Call it linked list, call it simple list to understand. Actually, it is a whole linked list which is put against one index. This is actually the concept of sets in Python, and it is due to this hashing technique that their computation searching in them is so fast as compared to lists. Now, let's see how we declare these sets in Python, how they are initialized. If you want to use them, how we can use them. First of all, I have written a code in example in which by using the set function we have declared an empty set, and we will run it to check. We ran it. It returned an empty set. It means that we have created a set, but there is no element of any kind involved in it. Same like this, if I assign some values in the same set, so for it I stored values in square brackets in the same set. Now assign items to it in this set. Now if I print this set, it will print out its value. Yes, you may have seen one thing in its printing, that the order in which we would have assigned these things. In set declaration, the output will not be like that in print output, but the output will contain all those elements that we have declared in sets. Let's do an experiment here. If we duplicate a value in the same set, so what output will it give against it? Let's check it. It has given an output of unique values given in sorted type. A, B, C are sets. If we even duplicate them, sets inbuilt that it does not allow duplicate in sets. This was declaration of one set, and if a set has duplicate values, it will automatically remove those values and only return unique values. After this comes that if we want to add any value to it, what we had before was that only A, B, C was included in it. If we want to add a new element to it, what function do we have for it? How does it work? When I run it, the add function, in my set element, the add function has added D item. Now the size of the set is 4CDAB. We saw what did the add function do with us. Till here we talked about the sets are mutable, meaning during execution we can manipulate them. We can change values in them, but there is one type of set that you cannot change during execution. Those sets are called frozen sets. How do we make them? In this method we cannot add anything by ourselves. If I run it, so first I declared this frozen set using the frozen set method, and in it to check if frozen sets allow us to add a new element or not. I ran an add function, and after that I printed the frozen set. When I will print it, it will give me an error that frozen set object has no attribute add, meaning you can treat it as mutable sets. That's why it generated an error that you cannot make the add function work on it. If I remove the add function and run it now it has displayed the output of the frozen set in front of me. Meaning frozen set is immutable and sets a mutable form. Same like this if we on sets, like in mathematics, perform different operations of intersection, of union, of difference, proper subset, disjoint sets. Built-in functions are available using which we can apply all these functions on Python.